In this video, we have learned the quadratic formula, and I'm going to walk through 5 different examples to show you how the quadratic formula works and a couple little things that happen here and there, like the square root could become a 0, the square root could become a negative, so what happens in those scenarios. So in this first example, we have n squared minus 2n minus 8 equals 0. Now, this is a unique example because we actually could factor this problem. So to show you that factoring and quadratic formula give you the same answer, I'm going to solve this problem both ways, and you'll see how if there's a problem you can factor, it will save you so much time to actually factor it and not use the quadratic formula. So if we were to factor this problem, we're looking for two numbers that multiply to negative 8 and add to negative 2. So we have n and n. It would be minus 4 and plus 2 equals 0. So now we have our quadratic factored, and we can just go ahead and use the zero product property. So set each one equal to 0. We get our two solutions of n equals 4 and n equals negative 2. So that took us literally 20 seconds. You can see how factoring can save you a lot of time as opposed to the quadratic formula. But we're still going to go through the quadratic formula so you can see that you will get the same answer. So for every problem, I'm going to start out by writing out the quadratic formula, and I'm going to determine what my a, b, and c are. So my a is the number in front of the n squared. In this case, it would be 1. B would be the number in front of the n, so I have negative 2. And then c would be the constant, which would be negative 8 in this case. Now we're going to plug these into the quadratic formula. I have x equals opposite b. The opposite of negative 2 would be positive 2, plus or minus the square root of negative 2 in parentheses squared minus 4 times 1 times negative 8, all divided by 2 times 1. Then I'm going to go through and simplify. So I have x equals 2 plus or minus, and I'm going to simplify inside my radical. Negative 2 squared is going to be positive 4. Again, this is that double negative here, so be careful. That becomes plus 32, all divided by 2. Then I'm going to simplify inside the radical more. I get 2 plus or minus the square root of 36 divided by 2. And then this is a perfect square, so I could keep going with that one. I get 2 plus or minus 6, all divided by 2. And now because I have all whole numbers, I can actually keep going and find the two solutions. So I can divide both of these by 2 and simplify it. I get 1 plus or minus 3. So then my two solutions would be 1 plus 3 or 1 minus 3, which obviously turns into 4 and negative 2. So I get one solution that's 4 and one solution that's negative 2. You can see how that took me a few minutes compared to factoring, but I still do get the same answer. So now let's go over another one. In this case, we have 2x squared minus x minus 16. This is one where a is not equal to 1. So off the top of my head, I do think this is one we could factor, but a lot of you hate factoring when there's a number in front of the x squared, so this is another option for you. So I'm first going to do the same thing I've done in all the other ones, figure out a, b, and c. So a is 2, b would be negative 1, c is negative 15, and I'm going to plug those into the quadratic formula. So I have x equals opposite b, so I have positive 1, plus or minus the square root. I'm going to kind of skip one step here. I know b squared is going to be negative 1 squared. Negative 1 times negative 1 is just positive 1, so I'm going to skip that one step. Minus 4 times 2 times negative 15, all divided by 2 times 2. Then again, going in the same order, I'm going to simplify inside the radical next. I get x equals 1 plus or minus the square root of 1. Again, a double negative. I promise you that is the biggest mistake people make with quadratic formula. So it becomes plus. Then we have 4 times 2 times 15, which would be 120. All divided by 4. So this becomes x equals 1 plus or minus the square root of 121 over 4, which then becomes x equals 1 plus or minus 11 over 4. And because we have all whole numbers, I could simplify this and actually find my two answers. So one of them would be 1 plus 11 over 4. One of them would be 1 minus 11 over 4. So this would be 12 over 4, which is 3. And then this one would be negative 10 over 4, which we could simplify to be negative 5 over 2. So let's try another example. So in this one we have x squared minus 3x plus 8. So a would be 1, b is negative 3, c is 8. I'm going to plug these pieces of information into the quadratic formula. For the sake of time, I already did it. This simplifies to become x equals 3 plus or minus the square root of 9 minus 32, all divided by 2. And then this becomes x equals 3 plus or minus the square root of negative 23, all divided by 2. Now we have an issue here. We have the square root of a negative number. This is not possible. Well, it is possible in Algebra 2. This is where you're going to get your imaginary solutions, but for Algebra 1, what we're going to say, whenever we get to the square root of a negative number, you can stop. There's nothing else you need to do. The square root of a negative number means you have no real solutions. And again, you have to say that word real because there are actually imaginary solutions. And just really quick, let's go over what that looks like on a graph. This would be a quadratic that's kind of not crossing the x-axis at all. So there's no places it crosses the x-axis, meaning there's no real solutions. However, there are actually some solutions that would make this true. You would just have to use something called an imaginary number. All right, we have another example because quadratic formula is so fun. So same thing, a equals 3, b equals negative 12, c equals 12. And I plugged everything in, making sure I'm careful of my signs. So now we have something kind of weird happening. We have inside our radical, we end up actually getting 0. So I have x equals 12 plus or minus the square root of 0 over 6. So when we simplify this, this ends up being x equals 12 plus or minus 0. But if you add 0 or if you divide by, or if you add 0 or you subtract 0, it doesn't change anything. So this part kind of just cancels out. You don't have a plus or minus. It just ends up being 12 over 6 or just 2. So in this case, we actually only have one solution. We have x equals 2. So what this means when we're talking about a graph, this means that this quadratic actually bounced off the x-axis right at 2, so it only actually hits the x-axis once. It is definitely not the most common example, but it does happen, so whenever you have a 0 inside the radical, you will end up with just one solution. Now for the last example, we're going over this one because there's only 2 terms, but you still want to use the quadratic formula the exact same way. You just want to be careful about what's your a, what's your b, and what's your c. So now in this example, I have a q squared term. So my a is going to be whatever number's in front of that. So I have 6. My b is going to be whatever's in front of just the plain q, but in this example, there is no second term. There is no q term, so my b is 0. It's not always going to be that b is 0. It could be c, so you have to be careful to actually look at what parts you have. And then my c would be negative 5. So of course, because we have a 0 in there, it's actually going to simplify even easier. So a couple things are going to end up canceling out. So inside the radical for this one, I have 0 squared, which is just 0. Minus 4 times 6 times negative 5, and you still have to be careful about that double negative. So just because the 0 squared is kind of irrelevant doesn't change that you have a negative after it. So we have negative 4 times 5 times negative, or negative 4 times 6 times negative 5 would give you positive 120, all divided by 12. And then for the sake of our class, this is really all you can do. Eventually, we will simplify the square root of 120. But for this problem, you can either leave your answer like this, or you don't really need the 0. You could just leave your answer x equals plus or minus the square root of 120 over 12.